Welcome everyone to the lecture series of Programming in C++. My name is Riman. So in this lecture series, I will assume that you have some previous knowledge about computer programs as well as programming languages. It is better to have a clear idea about C programming languages because it will be referred so many times in this course. The course objectives includes introduction to C, C++, and object-oriented programming. What are the features of different object-oriented programming? How to write some programs using C++, how to implement all the object-oriented features like classes, object, abstraction, encapsulation, overloading, polymorphism, and inheritance in C++. So this is going to be our course objective. So in today's lecture, we are going to talk about C++ programming and the programming style, how the rules and syntax are different from C. We are going to explore the concept of object-oriented programming. We are going to differentiate object-oriented programming with procedural-oriented programming, and so on. And also we are going to revisit some of the C programming concepts that are applicable in C++ as well, and draw some differences between C and C++. So C++ is a middle level language. Middle level in the sense it is in between, or it is residing in between the low level language and high level language. So we know that low level languages are only consisting 0 and 1s. That means binary values that are understandable by the programs, whereas high level language are languages that are understood by the humans as well as the computers. So C++ actually residing in the middle of them. That means it can be considered as a low-level language. That means hardware level programming can also be done in C++, as well as some high-level programming skills can also be used in C++. It was developed in 1979 at Bell's Lab. C++ can run on various platforms like Windows, Mac, and any other operating system like Linux, Unix as well. So this lecture will be helpful for understanding C++ theoretically and practically for beginners to the advanced software engineers as well. So why we are going to use C++? So as I said, C++ is a middle level language. It is very close to hardware. That's why it can give better control in memory management, performance, process management as well. It is very useful for robust software development. C++ is most widely used programming language in applications and system programming. It helps us in various ways to understand the differences between compiler, linker, loader, different data types, storage classes, and variable types and their scopes. So that's why C++ is very popular, and we should use and learn how to program using C++ as a computer programmer. So this is our first program. So whenever we are going to learn any programming languages, we are used to write a certain program that is named as Hello World program. That is a program that can print Hello World to the console or as an output. So this is our first program. So we are going to explore step by step all the stages or all the statements that are written in this particular program in the later slides. So C++ can be considered as a superset of C programming languages with added features of object-oriented principle, which means that any any C program can be run in a C++ environment as well. So let's look into the applications of C++ programming. So we can develop application softwares using C++ programming. Like most of the operating systems, like Windows, Mac, Linux, are actually written. At least some part of those operating systems are written in C++. Some browsers like Mozilla Firefox, Chrome, also written in C++. The most popular database software, that is database management software, that is MySQL, is also partly written in C++. Programming languages development like C#, Java, Perl, Unix Shells, PHP, and Python. These programming languages are built upon C++ programming language. In game development as well, C++ is used partially to give more control over the CPU and more control in the GPU as well. For embedded system like softwares for MRI machines, high-end CAD and SAM system, C++ can be applied there. So let's have an overview of C++. So C++ is a statically typed. What is a statically typed? A programming language is said to be statically typed when type checking is performed during the compilation time as opposed to the runtime. That means whatever type of variable they are available in any program, C++ program, the types are checked at the time of compilation. That's why it is called statically typed. It is a compiled language. That means the program is compiled, not interpreted. So we know that two type of translator from high level to machine level are available in case of programming languages. One is called interpreter, another one is called compiler. Compiler actually compiles all the instructions all together, whereas interpreter interprets or translates one instruction at a time. C++ was introduced to be a general purpose language. That means a language can be used for different purposes. It is a case sensitive language. Like if we have two identifiers, one having a capital letter, one having a capital letter, another one having a small letter, so both of them will be different because capital letter and small letter are different in case of C++. It is a free form language. That means spaces doesn't matter that much, but sometimes spaces are very important. So we are going to look into some examples where spaces are important and where spaces can be ignored in our programming, in our examples. C++ supports procedural-oriented language, object-oriented language, and generic programming as well. So these three are the programming paradigm. So we are going to learn about programming paradigm in a bit. Procedural programming, procedural style programming, object-oriented type of programming, and generic type of programming are also available in C++. So as I said, C++ is a superset of C. That means virtually any legal C program is legal in C++ programming environment as well.
Programming paradigm refers to the different approaches that can be taken to solve a particular problem. So different paradigm represents fundamentally different approaches that can lead to a solution of specific problems. So most of the programming languages can fall into one of the programming paradigms. Whereas some are there, those languages can have the elements of multiple programming paradigms. Like C++. C++ itself have two type of paradigm supports, like procedural oriented paradigm and object oriented paradigm as well. C programming languages only supports procedural oriented programming paradigm. Java, on the other hand, supports object oriented programming paradigm. It doesn't support procedural oriented paradigm.
Let's draw out the differences between procedural-oriented programming languages versus object-oriented programming languages. Procedural programming languages divides the program into functions, whereas program is divided into objects in case of object-oriented programming languages. Function is more important than data. That means the more focus is on functions rather than the data that are being manipulated in procedural-oriented programming languages. Whereas in case of object-oriented programming languages, data is more important and the concentration is on data and how the changes on data is happening. In procedural-oriented programming languages, top-down approach is followed, whereas developing an object-oriented programming follows bottom-up approach. Procedural-oriented programming languages are less secure, whereas object-oriented programming languages are much more secure than any procedural-oriented programming language, because the main concern in case of object-oriented programming language is data. Overloading is not possible in procedural-oriented programming languages like C, whereas function overloading is available in object-oriented programming languages like C++ and Java. New data members and functions addition is not easy in case of procedural-oriented programming languages, whereas in case of object-oriented programming languages, we can easily add new data and functions as a class form in object-oriented programming languages. Procedural-oriented programming languages based on unreal world, whereas real-world entities can be implemented as object in case of object-oriented programming. So let's look into the features of object-oriented programming. We are going to discuss them elaborately in later classes as well. But for now, just a brief introduction to all the properties of object-oriented programming. Encapsulation. Encapsulation means packing data and the functions that are operating on that data uh, into a single unit called capsule. So here the capsule is basically a class where we bind the data and operating functions on that data within a single class. Data abstraction means hiding all the essential details from the user and just showcase what are important for to that user. For an example, if we consider a car driver, so car driver knows you have to put the brake to stop the car, you have to press the accelerator to pick up the car, but he doesn't know what are the background principles that are working while he press the brake or he press the accelerator button, because that are not essential for that car driver. So data abstraction means hiding the non-essential details and only highlighting the essential details. In case of C++, class is actually doing all the work of data abstraction. Data hiding, this data hiding concept is closely related to encapsulation and abstraction. Data hiding means hiding the data part and do not let anyone handle the data except the similar type of group or someone from that particular group. Like suppose there is a class, no one can handle the class data except someone who is belong or who is an instance of that class. Inheritance is a process of reusing some of the properties from different classes. So inheritance basically provides the ability to reuse something that has already been implemented before in a new system. Polymorphism means having different characteristics have with the same name. A function called area can calculate the area of a triangle, can calculate the area of a circle, can calculate the area of a uh, rectangle depending on the inputs that are provided to that particular function. So polymorphism means having different form with the same name. So these are the basic features of any object-oriented programming language, and C++ actually supports all of them. So as a OOP, C++ can be defined as a collection of objects that communicate via invoking each other's methods. So that was I was trying to say that objects and class, they are the main important thing or main heart of a C++ program. Class and objects together implements all the encapsulation, data hiding, data abstraction. This concepts of object-oriented programming is implemented in C++ using this object and class. Also, methods are important part of a class, and instance variable are also an important part of a class. So each object has some state and behavior. So for example, if we take a dog, so dog has a color, name, and breed. Uh, so they are the states of that particular dog. Whereas behavior comes under whacking, barking, eating. So these are the behavior of the dog. So a object is called an instance of a class or a representative of a class. So classes can be defined as a template or blueprint that describes the behavior state that object of its type supports. That means classes can be called as a group of similar kind of objects that showcases same type of behavior and states, like an animal class. So animal class can have dogs, can have cats, and can have any other animal as well, because it's all the animals have some kind of similarity between them. So it is a class, a group of students. So a student can be a class where a name, phone number, address, that will be the behavior, or sorry, that will be the state of that particular class. And exams, marks calculation, this can be the behavior of a student. Methods and instance variable are part of a class, so they are called the members of a class. So instance variable are defining the states of an object, whereas methods defines the behavior of an object. Methods are responsible for manipulating the data or instance variable within the class. About the installation and compilation, in Windows we can use code block with Misc GW. It is a compiler as well as IDE that provides C++ environment where we can write, compile and execute our C++ program in Windows. In Linux, we can write our program in any editor, and we can use GCC through the command line to execute and compile our C++ program. C++ also have some online compilers. So online GDB, cpp.sh, they are some popular online compilers available in internet or online. So throughout this course, we are going to use Windows with code block, as well as we are going to use some online compilers. So now we can have a closer look into the C++ programming structure. So as you can see, this include statement. So we already know from C language that include statement is used to import the header files. So iostream.h is a needed header file for C++ programming languages. Like in C, we need stdio.h. Here we need iostream header file that contains all the necessary information that are required for a C++ program to execute successfully. And mind that .h is not present in case of C++. So whenever we are going to import or include this iostream.h header file, actually, we are not going to mention the .h. But if we want to include something or some header file that are meant to be for C language, like string.h, then we have to use #include string.h. But for all the C++ libraries, we don't need to put the header file. Next, the next statement was using namespace std. So the line using namespace std tells the compiler to use the std namespace. A namespace is used as additional information to differentiate similar functions, classes, variables, etc. So this is additional information, and this particular namespace feature is also introduced to C++ very recently. Now look at the next line. It's preceded with a double slash. So those who have some knowledge about C language, we know that the double slash represents a comment line. So this is a single line comment that will be completely ignored while executing by the CPU. The next one is int main. So main function actually indicates that this is the starting of the executable portion of a C++ program. Main function should always return an integer value. That's why the return type of this main is int. And within the main block, we are going to write all the executable codes that are required to be executed by the C++ program. So this is our first executable code, that is cout redirectional operator hello world. So this is a string literal. This hello world is a string literal. That means this particular statement is going to execute and print hello world on the display screen. So cout is the method that is correspond to print function or printf function in C. So cout is basically used to print something on the screen. So that's why this particular line will execute and print hello world on the screen. Then as this main has a return type integer, we have to return some integer value. So that's why this return 0 is actually returning the value 0 to the calling process. So this is the simplest C++ program, and this is not the class variant. That means this particular portion of code doesn't showcases the object-oriented part of C++ programming. It is rather the procedural-oriented part of C++ programming. Now compiling and executing any C++ program. So in Linux, we can use g++ filename.cpp command to compile the code or compile our program, and then /a.out to execute the code or execute the program. Whereas in case of Windows, you can have this kind of windows in code block software, where you will find a menu, build menu, where you can find three options: build, run, and build a run. So using these options, you can use this build option to compile the program. You can use this run option after compiling. That means after building, you can execute the program using this run option, or you can also use this particular third option, build and run, or you can correspondingly press F9 to execute your program on Windows platform. So now let's look at the role of semicolons in C++ programs. So semicolons are basically statement terminator. It is used to terminate all the statements. It indicates the end of any logical entity. For example, you can say x is equal to y. That is a valid statement if and only if we have put a semicolon here. Similarly, y is equal to y plus 1. That is also a statement because it is preceded by this semicolon. Add x comma y, this is also a statement. So all the individual statements in C++ are ended with a semicolon. Also, C++ doesn't recognize the end of line as a terminator. That means if we write or if we rewrite this particular set of statements, x is equal to y is equal to y plus 1, and add x comma y as this, that means one after another with semicolon in between, they will serve the same purpose. Because semicolon is the terminator of the statement. So this statement will be terminated by this semicolon, this statement will be terminated by this semicolon, and this statement will be terminated by this semicolon. So both of them actually does the same thing in C++. Now let's look into the blocks. So a block is a set of logically connected statements that are surrounded by the opening and closing braces. So within this main block, so this was the block from the previous example. So it is the main block. So a block starts with a brace and it ends with another brace. So whatever statements we are writing in between is called to form a block in C++. So identifiers are any name, any user-defined name that can be used to name a variable, a function, a class, a module, or any user-defined object. So these are the names, identifiers are the names that are given by the programmer to any objects, any user-defined objects. Objects in the sense, any user-defined items. So there are some rules or certain rules in case of C language as well, that the identifiers must start the identifier name must start with any alphabets or any underscore. So the first letter of the name of the identifier cannot be anything rather than underscore and numbers. So any other letter or digits are not allowed at the start, and the following, it can be more alphabets and underscore and digits. Special characters are not allowed in case of identifiers. And also identifiers are case sensitive, like capital M ANPOWER and MANPOWER are two different identifiers in C++. Here are some examples of valid identifiers. So underscore temp is valid, my name 50 is valid. So if it was 50 my name, then it is not a valid name, because uh, a identifier name cannot be start with a digit. It should start with A to Z, small a to Z, or an underscore, nothing else. And it can be followed by any numbers any digits or any underscore. No other character is allowed in identifiers. So C++ keywords refers to the reserved word that has some special meaning, and we cannot use this reserved word as identifier name in case of any user defined items. For example, while, for, int, break, continue, and so on. So there are so many: int, float, double, private, public, class. All of them are defined C++ reserved word, and they provide some special meaning to the program. So we cannot use them as a name for any identifier or any constant as well. So white spaces are important in some cases they are not important as well. So a line containing only white space, possibly with a comment, is known as a blank line, and C++ completely ignores it. That means if we have a white space line without anything, it will be considered as a comment and will be ignored by the compiler. So what are the white spaces? So blanks can be considered as white space. Tabs can be considered as white space. New line can also be considered as white space. And comments can also be considered as white space. That means in between two statements, we can have comments. So they will be treated as white space and they will be ignored by the compiler. But in some cases, white spaces are very important. So what white space does, it separates one part of a statements from another part. For example, you can have a look at this particular example: int space age. So I assume that you know the C programming languages. That's why int, you know that this is a data type, int data type, integer for to represent integers. So this is how we can define a variable in C as well as in C++. So int age, in between int and age, we must have a white space here, so that it can differentiate between it can separate these two int and age in this particular statement. Whereas if we can look into this particular statement, fruit is equal to apples plus oranges, there is no need to put spaces in betweens, though we have put the spaces in between because to increase the readability purpose of the program. So they are not required actually, but you can give as many spaces as you want if you want to increase the readability of the program, and the multiple spaces will be ignored in this particular scenario, whereas here also multiple spaces will be ignored and considered as a single space. But if we don't put any space here, this will not be understood by the compiler. So in some cases we need to put the spaces to differentiate or to separate one part of a statement from another one, whereas in some statement we don't need to put any spaces, but we can put anyway to provide the readability or to increase the readability of the program. So comment lines. So as we already know that single line comments can be used using or starting with double slash. So I have not shown that particular example because we have shown that particular example in the previous example as well. So comments are basically ignored by the compiler and they are used by the programmers to write some documentation within the program. So there are two types of comments: single line comments that we have seen earlier in the previous example. Like it starts with a double quote, sorry, not double quote, it starts with a double slash and ends with a new line. That means whenever you move into new line, it denotes the end of that particular single line comment. Whereas multi-line comment starts with a slash star and ends with another slash star. So these two are the examples of a multi-line comment. Though it is a single line comment, but because we have started with it is a slash starts and in between star slash, it will become treated as a comment. So rather it is not a single line comment. It is not a multi-line comment. It is a single line comment, though it is a comment. And this is another example where we have multiple lines within a multi-line comment environment. So C++ data types. So C++ provides three different types of data types. One is built-in data types that are unchangeable. Then we have non-primitive derived data type. That means these data types are derived from this primitive data type. That means some of the properties or some of the elements or one or more derived data types together forms this one or more primitive data types together forms this derived data types, and non-primitive user-defined data types are the data types that are created by the users. So let's look into details. So in primitive data types, we have bool. So this is new one that was not present in C. So bool represents a boolean value. It the storage it has of 1 byte, and it can only holds two values, true and false. Nothing else. No other values are possible in case of boolean. Character, it can be stored within 1 byte of space, and it can be stored to store any character, any single character from the program. int, so the storage size is 4 byte, and one more important thing, this storage is especially for char, int, float, and double, they are actually dependent on the architecture of the program. Sorry, architecture of the machine. So they might be at least 4 byte, at least 4 byte, at least 8 byte, but depending on the architecture of the system, they may vary on machine to machine. So float has a size of 4 bytes. So float and double are used to store real numbers like fractional numbers. Integer, on the other hand, is used to store whole numbers that are the natural numbers, positive and negative as well. So positive, negative, whole numbers. To store them, we need that integer, so that built-in data type int. And also we have another data type void that doesn't mean anything. That means if we don't have any data type, then we can say the data type is void. So, similarly, this void is used in case of function return as well. So when the function doesn't return anything, we put the return data type as void. That means to refer that void means nothing. So arrays are a collection of similar type of data. So it can be an integer array, it can be a character array, it can be a float array, it can be a double array, something like that. It can be a array of booleans as well. So arrays are collection of similar type of data. Pointers, they are used to store the address of another variable. So uh, actually the data type of pointer is unsigned integer, but they are used to store the address of another variable. Functions, we are going to look into that, and references, they are actually one kind of renaming of some variables. So we are going to look about, or we are going to talk about references later. In non-primitive data type or user-defined data types, we have enumerated types, we have structures, we have unions. So you might have learned structure and union in your C classes. Then we have classes. So this is very interesting, and we are going to learn about it. Then we have typedef. I guess you are heard about this typedef data type as well. So let's explore this primitive data type more. So we are going to talk about the range, the domain, and the size in memory. So I have already told about the size of the built-in data types, like the size, that means the storage that are required to store this built-in data types. So size of operator can be used to get the size of any data type. So size of int will return the size in bits of integer type. So what is a domain? So domain is the allowable values for some type. Like int only allows integer number, like the whole numbers. Real numbers are not allowed. Similarly, float allows any real number to be stored within that particular number. Also, the domain actually depends on the size or the number of bits that are used to represent that particular number. Uh, Similarly, Boolean has domain of only two values, true and false. So Boolean variable or bool variable cannot have any other value rather than true and false, or 0 and any non-negative value. That means 0 is treated as a false, and any non-zero value is treated as a true in case of Boolean variable. The range the range of any data type can be calculated using the formula minus 2 to the power size minus 1 to 2 to the power size minus 1 minus 1. So this formula can be used to find out the range of any number. So this char is represented by 1 byte, that is 8 bit. So that's why the range of char is minus 128 to 127. So there are some type modifiers to the predefined data types. Uh, they are called signed, unsigned, short, and long. So by default, every data type, like if I write int a, so int is by default signed. Signed means we consider the negative part as well as the positive part. But if we don't want to consider the negative part, then we must use the quantifier or modifier, actually unsigned. So what we have to do, we have to write unsigned int a. So now this a will be treated as an unsigned integer. That means the range of this unsigned integer will be starting from 0 to 2 to the power size minus 1. So now the range converts from minus 2 to the power size minus 1 to 0. That means it becomes, the lower bound becomes 0 and upper bound increases to 2 to the power size minus 1. Sort actually decreases the size of any variable. Like if you use sort int, the memory size will become 2 bytes. For integer, it is 4 byte by default, but if we use sort int, it will become 2 bytes. Whereas long, it actually increases the number of spaces required to store a particular variable. So long int actually has 8 byte of storage, whereas long double has 12 byte of storage. Now this typedef declaration. So creating a new name for an existing type using typedef. So typedef is nothing but rename. So we have some int, we want to rename it to suppose fit. So what we can do, we can write this statement, typedef int fit. So int will be renamed to fit. So this is how this typedef works. Now you can use either int distance or fit distance. So this is actually declaring a variable, integer type of variable. This is an integer variable, though we have defined it as a fit because we have renamed the integer data or int as fit. So typedef is nothing but renaming to a new data type. So that's why we have this syntax typedef type rename. Now enumerated types. So this is interesting. We can declare an optional type name, a set of 0 and more identifiers. So what we are actually doing, we are creating a new data type that has some set of values that serves as the domain. So we can have a set of 0 or more identifiers that can be used as a values of the type. So for example, so we have this particular syntax. Using this enum keyword, we can create a enumerated data type, whereas this enum name is the name of the new data type, and we have the list of names, that is the domain or list of values that are allowed for this kind of variable. So if we create a particular variable, like in this particular example, we have created this variable c. So the c can only have one of these values, red, green, or blue. And one more interesting thing, these values are by default indexed from 0, starting from 0, 1, and 2. So by default, this is 0, this is 1, and this is 2. So this C can have either 1, 2 or 3, or it can have either red, green or blue. You can also override or manually specify the names. So enum color, so we have specified this green as 5, right? But whenever we specify one of these names, the other names will be readjusted. So the previous one will be 1 minus this, so this will be 4, and the next one will be 1 plus this, so it will be 6. So now if we have a enumerate type of variable or color type of variable, that can only store 4, 5 or 6 or red, green or blue. So this is interesting. So similarly we can have an enum day of week. So possible values will be Saturday, Sunday and so on. So we can this day of week type of variable. So if we have a day of week type of variable, say enum day of week, say d1. So d1 now can have one of these values depending on the numbers as well. So Saturday will be treated as 0, 1, and if you want to Sunday to be treated as 0, so just put Sunday here and Saturday at the end. So this way enumerate data types actually works, and they are sometimes very helpful. So variable and scopes. So local and global variables are similar to C. So we know that two types of variables are available in C: local variables that are defined within the main or within any function, and global variables that are defined globally in the program. So similar kind of scope, variable scope is also available in case of local and global variable in case of C++ that are similar to C. Whereas we have, or C++ has introduces two different variables, class variables and instance variables, and they will be discussed later. So you already have some idea about the instance variable. They are inside the class. So they are class members, also known as member variables. So instance variable are also known as member variables or data member. So many names are there for instance variables. So instance variable are known as data members or member variable. So they will be discussed later. Global variables are initialized automatically by the compiler. Locals are not. So this is interesting. So all the global variables that are declared globally in C++ program will be automatically initialized by their default values. Like for int, it will be initialized with 0. For character, it will be initialized with /0. For double, it will be initialized with 0.0. So these are the default values, and only for global variables these default values works. For local variables, we have to initialize those variables by ourselves. Literals and constants. So literals are same as in C. So we have string literals. So they are enclosed within double quotes. We have character literals enclosed within single quote, and character literals should be a single character. Then we have integer literals or numeric literals, like the whole numbers 1, 5, minus 37. And then we have real literals or real numbers like 2.37 minus 6.25, or rather fractional numbers. So these are similar to what we used to have in C. We have introduced, or C++ has introduced Boolean literals, true and false. Like I said, two values are only allowed in case of Boolean variables, and these two values are true and false, and these are the new literals as well for Boolean literals. So constants are like normal variables, but the values, or the values of the constant cannot be modified. So there are two ways to represent constants. So using the define keyword available in C as well. So we have used this term like has define, max, 20. So the value of max throughout the programs becomes 20. Similarly, we have another way using the constant keyword. For example, this particular line, constant int length is equal to 10. So this constant, by preceding the type with this const keyword, we can define this length to be 10. And by convention, we always try to mention constant variable name within uppercase. So this should be max. Not should be. So this is convention. By convention, this is not a rule by the compiler, C++ compiler, but by the convention of different programmers. So all the programmers actually follows this convention so that there must be some uniformity in the programming. Uh, in the programming. So this is how you can use or you can declare constant variable in C++. Now for operators, so these operators are similar to that are available in C++. So arithmetic operators, relational operators, logical operators, bitwise operator, assignment operator, they are all similar and they are available in C as well. So I am not going to discuss these operators. Also, depending on the number of operands, we have three different categories of operators. One is unary, another one is binary, and another one is ternary. So unary operators are like plus plus, minus minus, binary operators plus, minus, division. So not is also unary operation. So this is belongs to logical operators. So logical operators are and, or, and not. So not is basically a unary operator. And internally we have this. This is also known as conditional operator. So the ternary operator has three different operands, and this ternary operator works on three different operands. So we are going to talk about this miscellaneous operators. So there are some special operators available in C++. So size of. So this is, I have already told or mentioned in previous slides, the size of operator is used to find out the size uh, of a data type. So if we put size of char, it should return 1 byte. So it will return 1. Conditional operator or ternary operator, just I said, it is a statement like this: A, B, C. So if this A, it should be a condition. It should be a condition. That means it is an expression that returns either true value or false value. That means a Boolean value is returned from this condition. If that value is true, so the output from this particular operation will be B. If the value is false, the output from this will be C. So this is how the ternary operator works. So I hope you have learned these things on C. So I'm not going to elaborately explain everything. Then we have comma operator. So this is used to separate two or three statements from one another. And whatever the output of this comma operator will be is the output of the last statement. So if we have A is equal to B, comma, B is equal to C, so it will take this particular statement as the result. Then we have dot operator and arrow operator. So they are the member operation operator. So you might have used them in structures. Structures and in structures and union, to access the members of an object or of a structure, we tend to use this dot and arrow operator. So when dot is used when we are creating an object of structure, and when arrow is used when we are creating an pointer of a structure, then we use the arrow object. Then we have cast operations. So this is like typecasting. So you can cast this particular float number into an integer using this cast operator. Then we have address resolution operator. So ampersand is an address resolution operator that returns the address of a particular variable. And then we have pointer operation that returns the value of a pointer. So this is a pointer operator. So now let's look at this typecasting and type conversion. So automatic type conversion actually converts lower size type to higher size type automatically. Like char can be converted automatically into int can be converted automatically into float can be converted automatically into double. So how this works basically? So if we have a statement like this, int a equal to 5, and suppose float b is equal to a. So in this particular uh, statement, this is an integer variable and this is a float variable, and the size that is needed to be, or rather make it double. So double b is equal to a. So to the size that is required for integers is 4 byte, whereas for double we required 8 bytes. That's why whenever this kind of statements are executed, a automatic conversion, so a the value of a is automatically converted to this double data type. And explicit typecasting is when we or users or the programmers explicitly cast the type using this kind of statements, the cast data type and the value. So suppose we have int a, suppose we have a float value, float f is equal to 2.5, and we have int a is equal to f. In this particular statement, f is a float type of data, and that has some precision. So whenever it is converted to an integer, this precision must be dropped. We cannot store precision in case of integer type of data. That's why we have to manually cast this particular value, this particular float value into an integer using this operation. So this is how this cast operator is working. Uh, and we have successfully casted this float value into an integer value. Now a will have this 2. The precision has been dropped. Uh, so they are not round off or anything. The precision is actually dropped from the float number. So that is how we can uh, explicitly cast some higher order value or higher size of values into lower size of values. So that's the end of today's lecture. On the next day, we are going to start from the control flow. Thank you, everyone.